This week we're looking at solving quadratics. The first several examples here we're going to use factoring to solve. The first one, we can bring the 9 over. Then this is a difference of squares. Set each to 0. And when solving, you get negative 1.5 and positive 1.5. The next one, we can just do common factoring of 5x, which leaves us with 2x plus 7. 5x equals 0, so x equals 0. 2x plus 7 equals 0, so x equals negative 3.5. The next two are trinomials. Rearrange so they're equal to 0. This factors to x minus 6, x plus 3. So we get x equals 6 and x equals negative 3. The next one, 2y squared minus 11y plus 15 equals 0. We end up with 2y minus 5 and y minus 3. So we get y equals 2.5 and y equals 3. Now the next two examples, I'm going to use the quadratic equation. For reference, it is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you have to have the equation equal to 0, so ax squared plus bx plus c equals 0. So we have a, b, and c. So x equals negative 7 plus or minus the square root of negative 7 squared minus 4ac all over 2a. We can simplify. 7 plus, underneath the root simplifies to 25 all over 4. So we'll have two x's, one for the plus and one for the minus. The first one we get 3, the second one we get 0.5. So our answers are x equals 0.5 and x equals 3. Now these ones work out to nice numbers. These could have been factored, but this will work for any quadratic. Again, first thing I do when I see something like this, I rearrange it so it's equal to 0. Now let's use the quadratic formula. So x equals negative 5 plus or minus the square root of negative 5 squared minus 4ac all over 2a. X equals 5 plus or minus the root of 121 all over 6. So x1 equals 5 plus 11 over 6 and x2 equals 5 minus 11 over 6, which end up being 2.67 and negative 1. We can also solve higher order problems. These two are ones that we can actually solve using factoring. We get p equals 0, p equals negative 2, and p equals 2. Now you notice the highest power was a 3, and we had 3 solutions. The highest power determines how many possible solutions there are to a question. The second example is what we call of the quadratic type. Sometimes you can actually use substitution, but this one's easy enough to do without. We can factor to x squared minus 9, x squared minus 4 equals 0. Each of those are a difference of squares, so x plus 3, x minus 3, x plus 2, x minus 2, equals 0, and then we get solutions of negative 3, positive 3, negative 2, and positive 2. Here's a couple more higher order ones. These ones we can just rearrange and solve for x. The first one, we add 8, giving us 380. divide by 4, which gives us 195, and then in order to get rid of the power of 5, we take the fifth root of 195. X ends up being approximately 2.87. Second one, same idea. We subtract 7, then we can divide by 6. This one's going to work out to a decimal, so it's just easier to leave it in fraction form for now. Whether 82 over 6 or reduced to 41 over 3, it's not a big deal. To get rid of the power of 4, we do the fourth root of the other side, but we have to do plus or minus. So m equals plus or minus 1.92 approximately. So whenever you have an odd root, you will only have one answer. Whenever you have an even root, you'll have plus or minus in two answers. We can also do some applications working with these. So here we have a right triangle. Often the best thing to do is start by drawing a diagram. So we know one leg is 12 centimeters longer than the other. And then we know the hypotenuse is 60. The hypotenuse being the side opposite the right angle. And when we say legs, it's the sides that aren't the hypotenuse. From there, we're working with a right angle triangle. We can use Pythagorean theorem. A squared plus b squared equals c squared. Or in this case, x squared plus x plus 12 squared equals 60 squared. Now, let's simplify this. We end up with x squared plus 24x plus 144 equals 3600. Rearrange it to quadratic form, so 2x squared plus 24x minus 3456 equals 0. And let's just use our calculator to solve this. We'll get x1 equals 36, x2 equals negative 48. So the answer for the x is 36. We ignore because it's negative for the 48. But if you take that 36 and you add 12 to it, you get the 48. You'll see this kind of symmetry happen quite often with geometry questions. So the final answer would be 36 centimeters and 48 centimeters. Here's another word problem. This one working with a rectangular sheet, so let's draw out a sheet. We're saying it's 40 centimeters longer than it is wide, and then we're cutting out corners from each corner that are going to be 10 by 10. And then we're going to fold up along these dotted lines to give ourselves an open top box. So a box with no lid. Now the dimensions of the box, well, we're going to have x minus 20, 2 times 10, because we're taking 10 away from both sides. X plus 40 minus 20, which ends up being x plus 20, and then a height of 10. Now volume is length, width, height. Well, our length is x plus 20, our width is x minus 20, and our height is 10, and we were told the volume was 77,000. Now we can divide by 10. Which is 7,700. Multiply out the left-hand side, which is just a difference of squares, so we're going to get x squared minus 400 equals 7,700. Rearranging, we get x squared minus 8,100 equals 0. Put this in our calculator, you get x1 equals 90 and x2 equals negative 90. Obviously, it's the positive one. We can't have a negative length. But 90 is only the one length, so we do 90 plus 40 to get the other length. So therefore, the original sheet was 90 centimeters by 130 centimeters. We can also graph quadratic equations. Now, when we go to graph quadratic equations, we look at 4 key points. We can find the x-intercepts where it crosses the x-axis, the y-intercepts where it crosses the y-axis, and the vertex, which is the uppermost or lowermost point. Let's start with the x-intercepts. So we set y equal to 0. So we have 0 equals 6 minus x squared. Rearrange this. you end up with x squared plus x minus 6 equals 0. Whether you factor or use your calculator, you'll end up with x equals -3 and x equals 2. The y-intercept, we can just set the x equal to 0. So y equals 6 minus 0 squared, which is just y equals 6. And then lastly, the vertex. Well, we have a formula for the x value of the vertex. It's just negative b over 2a, which is just the first portion of the quadratic formula. In this case, we'll have negative 1 over 2 times -1, which ends up being -1/2. But that's only the x value. To get the y, we plug the -1/2 into the original equation, giving us 6.25. So the vertex would be the point -0.5, 6.25. Now, plot all your key points. So we have x equals -3, x equals 2, y equals 6, and then we have -1/2, -6.25, which is approximately there. And then try and connect the dots as smoothly as you can.